Imagine this. You're standing on a construction site in the middle of the desert. The temperature is 48 degrees Celsius, sand is blowing everywhere, and your mission is build the tallest building the human race has ever created. No architect in the world had ever done it before. No engineer knew for certain whether it was even possible. And yet, 12 years later, this structure stands proudly in the desert of the United Arab Emirates, the Burj Khalifa, 828 meters tall, 163 floors, and to this day, the tallest building in the world. But how do you build something like this? What problems had to be solved? And what secrets are hidden inside this gigantic tower? That is exactly what we are going to find out today. Dubai in the year 1999. The city is growing at a breathtaking pace, but hardly anyone in the world knows it. Sheikh Mohammed bin Rashid Al Maktoum, the ruler of Dubai, has a clear vision. Dubai should appear on the world map, not as an oil state, but as a global center for business and tourism. And for that, he needs a symbol. Something the entire world can see. Something no one will ever forget. The decision is made. Dubai will build the tallest tower in the world. The architectural firm Skidmore, Owings and Merrill from Chicago is given the contract. Lead architect Adrian Smith designs a tower that should not only be tall, but also elegant. Almost like a flower growing out of the ground. The inspiration for the shape? The desert falcon, and a regional flower called Himenocalis. Its spiral-shaped petals were directly incorporated into the structure of the tower. That is why the Burj Khalifa has its characteristic, tapering, three-pronged floor plan. This is not just beautiful, it is physics. Because this floor plan significantly reduces wind pressure. And wind is the greatest enemy of an 828-meter tower. Now comes the first major challenge, the ground beneath. Dubai sits in the desert. Underneath, soft sand, saltwater groundwater, and unstable rock layers. Not an ideal foundation for the heaviest skyscraper in the world. The solution? A pile foundation, and one of the most massive ever built. The engineers drive a total of 192 concrete piles into the ground. Each pile is 1.5 meters in diameter and up to 50 meters deep. These piles reach through the soft sand all the way down into more solid rock. On top sits a massive concrete slab, the so-called base mat. It is 3.7 meters thick and weighs around 110,000 tons. But there is still the problem of salt. The groundwater in Dubai is extremely salty. Salt attacks concrete and steel from the inside out. Over decades, it can destroy an entire foundation. The engineers therefore develop a special concrete, a mixture more resistant to salt water than any concrete ever made before. In addition, the foundation is coated with a special protective layer of epoxy resin. The foundation alone takes over a year to build, and the actual tower has not yet grown a single centimeter into the sky. In the year 2004, the real construction work begins, and now the pace becomes breathtaking. At times, up to 12,000 people work on the construction site simultaneously, around the clock, 7 days a week. Most of them come from India, Pakistan, and Bangladesh. They sleep in camps near the site so that no valuable time is lost. The concrete for the tower is produced using a special mixing process. In 48-degree heat, normal concrete would harden too quickly and crack. That is why the mixing water is cooled with ice, and all concrete work takes place exclusively at night when temperatures drop slightly. The heart of the tower is the central concrete core, a massive shaft that runs from the foundation all the way to the tip. It contains elevators, stairwells, and all supply lines. This core is the backbone of the building. It carries the load and keeps the tower standing. Around the core, the floors rise higher and higher. The construction workers use so-called climbing formwork, concrete molds that automatically shift upward as soon as one floor is complete. The system runs almost like a machine. On average, a new floor is completed every 3 to 4 days. To transport materials upward, several external lifts are installed. They carry construction workers and tons of material into the heights, up to the then uncharted elevations of 500, 600, and finally 700 meters. Imagine standing on the roof of an 800-meter-tall building. The wind is howling at over 150 kilometers per hour. The building sways, noticeably. That is not a flaw. That is intentional. A skyscraper must be able to move in the wind. If it were too rigid, the forces would break it. But it must not move too much either, otherwise the residents would feel seasick, and the structure would fatigue. For the Burj Khalifa, the engineers developed a brilliant solution: the spiral floor plan design. Normal skyscrapers struggle with what is called the Kármán vortex. When wind sweeps past a cylindrical building, vortices form on both sides, alternating left and right. This sets the building vibrating, much like a tone that makes a wine glass tremble. On the Burj Khalifa, the floor plan slightly changes its shape and orientation at every level. This prevents any uniform vortex from forming. The wind cannot synchronize. The vibrations remain minimal. Even so, the tip of the tower moves up to 1.5 meters to the side during a storm. That sounds like a lot, but for a building of this height, it is remarkably little. In addition, more than 40 different versions of the Burj Khalifa were tested in a wind tunnel, a special laboratory where miniature models of the tower are exposed to wind, before the final shape was determined. A building with 163 floors obviously needs elevators, but ordinary elevators would have failed here. The problem: the longer an elevator cable is, the heavier it becomes. Beyond a certain length, the cable would snap under its own weight. For an 828-meter tower, there is no elevator cable in the world long enough. The solution: multiple elevator zones stacked on top of each other. The tower is divided into 3 sections. On certain floors, the so-called sky lobbies, visitors transfer from one elevator to the next. The elevators themselves are high-performance machines. They travel at up to 10 meters per second, equivalent to 36 kilometers per hour. From the entrance hall to the observation deck on floor 124, the journey takes less than a minute. In total, there are 57 elevators and 8 escalators in the building. The logistics planning alone, who travels where and when, so that no waiting times occur, was an engineering masterpiece in its own right. One more challenge that almost no one knows about: where does an 828-meter tower in the desert get its water? The Burj Khalifa has its own water supply, one as large as the water network of a small city. Around 946,000 liters of water are consumed every day. That is roughly equivalent to 20 Olympic swimming pools. The water comes from a seawater desalination plant. It is processed, pumped into massive tanks in the basement of the tower. And from there, high-pressure pumps push it all the way up to the highest floors. But then something fascinating happens. In the upper floors, the air condenses against the outer glass panels, much like dew on a cold glass. This moisture is collected and flows into a collection system. Up to 15 million liters of condensed water are harvested this way each year and used to irrigate the surrounding landscape. The Burj Khalifa produces its own water from the air, in the middle of the desert. On January 4, 2010, the Burj Khalifa is officially opened. 6 years of construction, over 22 million working hours, around $1.5 billion in building costs, and the result, a structure that has redefined the limits of what is possible. Proof that human ingenuity knows no natural ceiling. The Burj Khalifa is not just the tallest building in the world. It is the result of thousands of intelligent decisions, under extreme pressure, in extreme heat, on extreme terrain. And perhaps the most remarkable thing of all, every day, thousands of people enter this tower. They ride the elevator upward, look out the window, and probably never spend a single second thinking about what it took to make that view possible. If you enjoyed this video, subscribe to the channel and leave a comment. Which megastructure should we explore next? See you in the next video.